There we are. Hello everyone! Okay, we are back. And I kinda just want to open chat again, like I always do. But my internet just died a little bit. You have to say it in that way, because of course, YouTube. Alright, there we go. I can read chat, boys. I was almost late today, actually. Believe it or not. But here I am. But I have nothing prepared right now. So, what were we doing yesterday? I don't remember. One thing that I do kind of want to talk about, just for 1 second. That is a video that is gonna come up in 2 hours now? Yes, right. At 10 PM. So right when this stream is going to end, I'm uploading a new video to the channel. Can I show you like a sneak peek? Let me get a sneak peek for you all. Oh, it's Mistress Maria, welcome. Yes, I'm just looking up, right? Downloads. I think this is the thumbnail. That's enough. That's enough. You've seen enough. You've seen everything that you need to know. Yes, I'm very excited for this one. So I've never done anything like this. At least not on this channel. Of course, I've made some gaming content on another channel. But, well, didn't go so well. Hey. Maria. Keep it down, please. Well, in any case, I thought this game, I found this game right. I thought this game fits so perfectly within this channel, and I thought, hell yes, let's make this video. I haven't made any video yet for this Friday, so let's just do it. You know, let's just do it. I have nothing planned, I have time. So I just took this afternoon, and in a couple hours I played the game. Sorry, I'll try to keep it PG-13, lol, yes. Thank you. Nah, doesn't matter. In any case. Right, so in only a couple hours I created it, like I recorded it. I even downloaded the game in that time, and I edited it, uploaded it, did all my keyword stuff. Yeah, I think I made the thumbnail. That was surprisingly difficult because, you know, I had my face and all of that, so I had to like get rid of the green screen. Now I'm lucky that I have a green screen, or well, my walls are green. I'm pretty sure this music is copyright. Is it? Like it says very specifically. 90% sure. That's weird. Because it says specifically on the playlist that it is not copyrighted music recognized, and I guess none of these have been claimed. Like none of my previous streams have been claimed. I'll just double check. No. So I think it's fine. Because I have used this music before, right? I'm messing with. Hey! Ah, you got me. Dang it. Nope. Get wrecked. Yeah, I deserve that. Fell for that one too easily. Okay, well. Anyway. Let's just do something, right? Let's actually do something. Right, what did we do yesterday? Let's just check it out. Come on, run. Yes, I'm a very impatient man. Ah, yes. So our camera works now. Oh, yes. I can't press multiple buttons at the same time for some reason. I thought I didn't use a switch, but maybe that's just something to do with the callback functions. I'm not sure. But that just looks... ain't she a beauty? Oh, look at that. Awesome. Well, today, I thought I wrote something down about what I wanted to do today. But I'm not sure where, but it's in here somewhere, right? I usually just write comments in my code about what I want to do. Maybe I didn't. I guess I didn't. Well, never mind. Guess we're just going to do something then. Wasn't it like in my vertex shader though? Or like something that I had to do in my vertex shader. That's something that I remember. Oh yes, of course, in the render manager. Right here. Yes, this is my to-do. Make this a list. That is what I wanted. So right now we are sending so many voxels to the graphics card that we really don't need to send there. Voxels that have 0 unoccluded faces. Yes, that's how you say it. 0 visible faces, and yeah, we're sending it to the graphics card, and the graphics card has to check all those faces and say, well, I'm not drawing any of these, and that's a bit of a waste. So let's actually go ahead. Well, I guess this has to be a list then, right? A list of uint, and we will call that data equals new list of uint, and we'll just make it empty. Maybe we just reserve chunk size, and then maybe later we can like fit it to actual size. So you can say something like data that shrink, reverse, sort, trim access. Sets the capacity to the actual number. I don't think it matters. You know what? It doesn't actually matter, right? It doesn't actually matter. Yeah, because here we just set the length to the size that we actually have. So then all the excess bits at the end we just don't read into OpenGL. So that's fine, that's totally fine. So then here we can, instead of doing this, we just add the data. We can just do .add. We just add D. And because we actually store the position, the X, Y, and Z position within D, it doesn't matter that they are in like the wrong quote-unquote order, because there is no wrong order. Now what we can do here is we can say something like, okay, if all of these are occluded, if all of these are ones, then, you know, don't do anything. So I guess what we should say, so if all of these are ones, right? So all of them have to be ones. So I guess what I can say is something like uint, and then occluded, yes, equals 0. And then for every single one of these, I can say occluded. And I don't really like this formatting. Can I not have this formatting? Can I just... Wait, what if I use just a comma here? That doesn't work in C#. Crazy. So in C++, you can just put commas behind lines instead of semicolons. And then it will just see it as one line. So you can just do 2 separate instructions on one line. And it's nice for things like this. But I guess in C# it doesn't work. Good to know. But now, if I now press reformat code, yeah, it's gonna do that. Oh, I don't want that. I don't want that. So it's going to make things very big. Very, very big. I don't like it when things are big. Hey, Federico. One thing I've been thinking is why you need to send and store XYZ for each voxel if the voxel XYZ depends on the position in the array. You have come into this stream 5 seconds maybe too late. Because I just explained that. I just changed our array to a list. And what we're doing now is we are going to count how many faces are occluded in here. And if all 6 faces are occluded, we are simply not even going to bother to put that in a list. So that will save us a lot of data. Sending to the graphics card. But on the other hand, well, you know, I do need the X, Y, and Z. That brings me to think, actually, now that you say it that way, I'm starting to doubt myself. Let's say that we have just a not blinding paint document, and then let's say that we have our 32 by 32 by 32. Yes, I know I'm drawing again. I'm so sorry. At some point, you're gonna have to use different rendering method, otherwise it might become too slow. I think I don't know, don't take my advice. I'm a soup addict with 69 IQ and a rock for a brain. Aren't we all soup addicts? Aren't we all soup addicts? In any case. Yes, the geometry shader is potentially slow. It's a bit of an experiment, but we'll see where we can get. But let's say we have 32 by 32 by 32. Let's now say that we are just going to send the colors to every voxel, right? So only the colors. But on the other hand, we also still do kind of need the occlusion. I do definitely want the occlusion. So I need 2 bytes, also one for the occlusion. So if we do it this way, if we just hardcode in an array, so we just say our uint array data again. Hey, there is nothing wrong with being a soup addict. No, it just said I'm a soup addict. Everyone's a soup addict. It comes down to it. So we have a uint array data, and it will just be like of some size, right? 32 x 32 x 32. So every single chunk will be exactly 64 kilobytes in size, right? Because that is about 32 kilobytes. Believe it or not, 32 times 32 times 32 is about 32,000, which is chef's kiss. Nice maths. But also, these are 2 bytes, so 64 kilobytes. While on the other method, we are going to have to send 4 bytes, right? We're going to have to do the x, y, z, and c. So it will be 4 bytes. But also now potentially we can remove the inner layer here in the best case scenario. Right, so in best case scenario, we will have 32 by 32 by 6, which will be and then times 4, of course. Let's check that out, because I definitely don't know that. So 32 times 32 times 6 times 44. It's 24,000. So that is 24 kilobytes. So that is approximately 3 times as good in the perfect scenario. Now, of course, we might have an imperfect scenario, but still the times 3... the 3 times better will definitely give us like some, you know, some leeway. So I think it's fine. You can trust the soup addict. Yes. ST equals suit. By the way, totally PG-13. Yes. Ah, yes. Like the S star T is definitely just suit. Yes. So I do think that the list is then more efficient, now that we have calculated this. But it is good that you brought it up, Federico, because, well, you know, maybe using less data overall and using just an array was better. I didn't actually calculate it. Okay. Now, we can continue with this, I suppose. Plus, can I not make this any... No, I can't. Can't make it any better, boys. Oh, pain. I don't like this formatting. Oh, wait. This was east. This was west. Suppose I can do all of them at once, right? Maybe I should make like a quick function for all of this. And plus occluded. And then this thing. Oh, actually, if you do it with alt, then the formatter can't kick in. Oh, that's beautiful. Thank you, formatter. Okay, so now if... Right, Do I already need the X? Do I already use that somewhere? No, I don't. And I also don't use the color somewhere. So I suppose I should first calculate occluded here than anything else. We can also turn this into a multi-threaded function, of course, but for now, it doesn't really matter. If occluded is bigger or equal to 6. I don't know why it would be bigger than 6, but I always like to have some sort of thing in there, just in case that your integer math doesn't add up. And this actually does need X, Y, and Z. So we do need X, Y, and Z. And then occluded, but we don't need the color set. So then if occluded, oh wait, equals smaller than 6, right? So if not all faces are occluded, then we need to generate the color. We need to generate D, and then we need to put everything in here. Right? Then in here we can do data.count, which will not be equal to the capacity, but equal to the actual number of elements. Yes. Times that, and this will have to be a array, right? So I actually have to do like 2 array here. I'm not sure how slow that is. Static copy. Yeah, of course, this list, it has like a set size. So we can definitely just put this outside and not constantly remake it and remake it. But again, we're just trying to optimize for the graphics card right now. Is Y or Z the up axis here? Y is the up axis, Z is the depth, and X equals like left and right for the default camera position. So yeah, so Y here is top and bottom, Z is north and south, X equals east and west. Okay, so this here is correct. But then we do, of course, need to store here the correct number as well. So that is data.count for size. And then I think the rest should just work. Let's go here. I do think it's faster. I'm never ever seeing 3 anymore. Yeah. Oh. That's looking funky. Why is this looking funky? Oh, because there is a chunk next to here. Oh, I didn't know. Oh yeah, of course, I had a couple chunks right next to each other. Okay, no, then it makes sense that it's looking funky like that. Yeah. Okay, so from inside of here, what I first of all want to do is I want to make sure that I'm only drawing the clockwise faces and not the counterclockwise faces. Right, so that means that I should be able to see like the outside. No, wait, the other way around. I only want to see counterclockwise faces, not clockwise faces. Then I should only see like the outside of the cube, and the inside of the cube should not be visible. It should be see-through. That will save more resources again. So I can do that in the engine. Then, okay, I have to remember this somehow. But it is the onload. gl.enable enable cap. Not depth test, we already have that one. Backface culling, yes, that's it. Cull face, yeah, I'm pretty sure that's it. gl.cullface and then set it to cullface mode. Cullface mode and then dot back. Don't I also need like cullface direction? Or rotation, or I don't know. I'll check that in a second. Does this work? Even? I can actually see the faces that I... No, never mind. I can't see the faces that I want to see. Right, so some of these are drawn correct. Some of these are not drawn correctly. Yeah, so the top and bottom are the wrong way around. The front is right. The left is right. The right is not right. And then the back is not right as well. Okay. It's weird that top and bottom are both incorrect. Because for the other ones, it's just like one side that is correct and the other one is not, which kind of makes sense, right? Yeah. Okay, let's check this out. I guess it is in Geometry Shader, right? Where I generate all of the triangles. Okay. So north. You know what? You know what I can do here? It's because we are now doing triangle strips instead of triangles. If we have like a face, right? Like this will be like the top face. We can just draw this and then this, and that will give us 2 triangles, right? In the triangle strip. So we just go this way. So we only have to get 4 vertices here. So let's actually do that. So if we are from the top, right? This is north, so let's do the top first, because I think that makes most sense. Top, right. So the top is 1 in Y, yes, and then 0, 0 there. Yes, that makes sense. Then we go to the right one. Yes, then we go up 1. Then I don't want to end primitive. And then I want to go back to 0 here. That one. Like this. And then I want to end primitive here. Primitive. Okay, does this work for the top? Because if so... It only draws a little bit. It draws like the left, right, top, but then the left one it doesn't draw. Right, how do triangle strips work? Just asking for a friend. Triangle strip OpenGL. Because I thought that was how it works. So 1, 2, 3, 4. Yeah, that should just work then, right? Oh, now I'm going 1, 2, 3, 4 like that. Yeah, okay, so I have to go zigzag. Okay, wait. So this is the bottom left. Then we go to the right one. Yes, then we go up 1, but then we have to go... No, I shouldn't go up 1, I should go 1 back. So I need here. Need to switch these 2 around. Yes. You are missing a point. Microsoft has been wanting to remake Minecraft in C# for a while, so if you add terrain generation, texture atlasing, modeling capability and some other things, Microsoft may give you money. And you go yoink. You need 5. 1, 2, 3, 4, 1. Do I? Here it only uses like 1, 2, 3, 4. And then it goes on to the next triangle. So I think I have to like zigzag it. Like this. So now I go to the... This is like my bottom left. Then I go on to the right. Then I go to the top left again. And then to the right again. So I make a Z, sorry. Sorry, you said. I don't know... I'm not even sure if this works, but... Don't be sorry, dude. Now you don't see anything, so I think we are drawing it in the wrong order now. Right, how do I reverse the order? I do want to start here. Right, so instead of then going to the right, I should go up. That makes sense. Right, then I should go to the bottom right, which is this. And then up 1, yeah. Trying to envision this in my head. Like this. Yeah, look at that. So now we need 2 less vertices. Look at that. Even faster. Oh boy, we've passed this F, boy. Okay. Let's see. Let's try the same thing here for the bottom. So, right, so just to make it a bit more clear. So this doesn't work. Instead, if we have like the top side here, we have to draw it. No, that's not the color that I want. This is the color that I want. That's the background color, yeah. I have to draw it this way. But then this is counterclockwise and this is counterclockwise. No, that's clockwise. I don't know. But in any case, it calls this. Right, my backface calling is calling this. So instead, we actually have to draw it even a little bit differently, which is this way. That's how we're doing it now. So this one is also incorrect. Okay. So let's look at the bottom face. So we start off in the left corner, right? Then I do think we should go one to the right. Then we should go one up and one back to the left. So that is this way, yes. And then we should have the final one like this, yeah. Which is in the 1-1 corner. And then we can just end the primitive there. Okay. So this is right the other way around. Because this is the bottom face. And that almost works. It works like for half. Okay, did I do something wrong? That's 0. Then I go for the one to the right. Then I go back and one to the front. Go back to the right. Yeah, that is a Z, right? Okay, let's try it the other way around. Let's go up first. Then we do the other one. So we turn the middle two around. Is it like going to draw the other, like half? No. Oh, I end the primitive here. Oh, that's the issue. I think I found it. I forgot. I forgot, boys. Oh. Beautiful, isn't it? That is beautiful. Okay, so now I want to do the front side, which is the north side. That's the side that we always look to. And I'm guessing it draws correctly right now. So going one to the right. And then going the other way, which is to the top, but then left, right? And then the other way around. And then like that corner. And then I want to end the primitive here. I think this works. Yeah, so this looks very strange. I'm definitely... I think I'm drawing this wrong? You think I'm... Maybe, right? But I wouldn't. Nah. Nah, this looks correct. This looks correct, boys. What the hell did I do this time? This... Oh, here the Z changes all of a sudden. Oh, and this is just the same? Okay, hold up. So the Z, right, in the north side. Wait, what? Oh yeah, that should be 1 in the... No, that should be 0 in the Z. Should it be 0? What does this used to be? Like, what was this? Let's just go back. I went too far back, didn't I? There. Yes. Okay, north. 001. Yeah, and then 101. This is 111. Okay, so this has to be 1 at all times. 1, 2, 3, 4. And remove these. Move this one. Okay, so we have 0, 0. Then we go 1, 0. Then we should go 0, 1 and then 1, 1. Try that again. Yeah, that looks way better. That looks way better. Okay, so that's the proper north side. Yeah. Then we need a proper east side. East side is positive X, so that is towards the right, which is not drawn correctly right now. Okay, so X is always 1. Yeah, that makes sense. And then we start at 0, 0. Then we should go to 1, 0, then to 0, 1, and then to 1, 1. Then we should end the primitive there. Once you see the pattern, it's not that bad. There we go. Bottom is still working, by the way? Yeah. Okay, perfect. Then we have the south. So the south is... Is the south working right now? I actually don't know. I didn't check. Let's just go straight through. Going straight through. And no, the south doesn't work. Okay, good to know. So we have 0, 0, 0. Then we have 0, 1. Then we have 1, 0, and then 1, 1. Then the end primitive. Okay, now south should work. Yes, south works. Awesome. Then we have west, which is the last one, and the west side does work right now. Right, so what do we have? We have center plus fact 4. 0, 0, 0, right? The X always stays 0. This is correct. And it should be this way. 1, 2, 3, 4. Remove you. Remove you. And then everything is fixed now? Yeah, looks like it. This was east. Yeah, and the other side was west. There we go. Right, so now it's only 6 times 4, which is 24 vertices. And then with a bit of triangle or a bit of camera trickery, we can even make this 12 vertices max. Look, so this should always work. And now draw only the faces looking at the camera. Yes, 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 yes. Let's go ahead and do that. Though I also kind of want to stress test it just a little bit without crashing the stream like yesterday. Or almost crashing the stream like yesterday. Let's go for like 4 by 4 by 4. And this should be -2. Make skybox now. Ooga booga. We can actually make just one big voxel as a skybox. And then draw the front instead of the back. Or draw the back instead of the front. That'd be pretty cool. So this 4 by 4 by 4 requires about 3 milliseconds. If you can like pause it for a second, you can see it's like sometimes it's 5.5 for some reason. I don't know why. Some frames are really slow and then the rest like 2. Let's say an average of 3. And this is 4 by 4 by 4, boys. You can see that I'm always drawing the exact same voxel. So you can see that like here is like the same pixel as there. See that? You can't unsee it now. Okay, let's see in here. Yeah, so this is the top side of the next one. So you see there's no glitching anymore because I'm only drawing one side at a time. But you can see that I'm still drawing an insane number of voxels that I shouldn't have to draw. Right? So first of all, let's do the camera thing. Let's do the camera thing and then see if we get an improvement. Wait, actually, to do it even better, even more professional, because we are professionals, right? takes a sip of water. Very much so. I guess we should make a timer class real quick and get like an average time going. Then we can really see how much the camera trick will improve the code or the speed. I literally dipped my hand in my soup because my rock brain confused the soup bowl for the chips bowl, and now there's cold soup all over my hand, and oh god, what do I do? I guess you gotta eat it from your hands, dude. Oh, that's pain. Losing precious soup, man, that hurts. Okay, let's see. If I make like a timer class, right? Like in here. I cleaned my hands and took some chips. They tasted like soup. The soup's everywhere, man. Oh no. Soup flavored chips. Like, don't they have that stuff? Delicious, you should lick it. Hell yes. It's the soup invasion. Timer. Public void should like have a start. Where it will like start counting down like actual time, like Unix time or something. And then it should have some function like public void void and then add, what should it be? It should like add sample. It should be like a double DT. Public void get mean time. And then public void resets, and then something like public void restarts. No, I guess reset and restart is the same thing. I guess I can just do like restart instead of reset. Okay, so I should have like a private something something something. I don't even know like what, like uint, whatever. Unsigned long. I don't know, like start time. Start time equals 0. I want to, but I'm scared that it'll taste horrible because of the flavoring that rubbed off the chips I ate with my soup hands. Can feel the soup. Hell yes. The private list doubles will be samples equals new list of doubles. Start time equals, and then something like system time, timers, daytime even. I have a stopwatch, of course. Timer. The daytime, I guess. And then UCT now. Unix epoch. I think that makes sense, right? And then ticks. Like total ticks, and that's in long. Turn that into a long then. Oh, I washed some of the soup down the drain, which means it's gonna spread to the ocean. Oh, snap. Oh, next time that you eat a fish, you can think about how it has marinated in your soup. Ticks, days, years, seconds. I don't think seconds is that accurate, is it? Add milliseconds. Add years. Get formats. Data saving, subtract, local to long, blah blah blah. To universal time, try format. Yeah, no, like ticks should be fine. I just don't know how many ticks there are in a second or in a millisecond. I should look that up. Soup in your face. Next time anyone eats seafood. And restart, start time. Should be the same thing again. And samples.clear. Ruined the entire franchise. Add samples should be samples.add pt. Then get meantime, that should actually be a double. Then you should have like a double. Wait, do I even need a start time? I can just have samples, right? I can just put like time samples in here. Yeah, why do I even bother? Start or restart. Like start doesn't even do anything, but I guess I can do like samples.clear again. Start is the same as restart, I suppose. Double it. Get meantime should be return. And then samples. You have destroyed seafood. You've ruined it. Yeah. Boy, you made it like 10 times better. Average. Yeah. Just use the link function here, it's fine. Can we make read only? Yeah, that's true. I also can just have a restart function, right? Okay. So now what we can do, where's this? We can do private timer equals timer. Ah, it should be static. Yeah, that's true. Static read only timer. Yeah, and then in here I should do timer dot add sample, which will be arcs times 1000. 0.0. Right, what is this? That's also double? Yeah, so that's that many milliseconds. You should also have a private, maybe in timer itself, I can add like a counter. Go to definition and then say something like public and then long and then count. Return samples.count. Yeah, and public double, and that should be mean time, should be samples.average. There we go. Oh, excuse me. Right, so now we can say if timer dot count is greater than 1000, then console.writeLine. And I should do something like timer dot meantime milliseconds. Then we should probably also do something like timer dot restart. And else timer dot add sample. Right, so let's run this. So every 1000, so it would be about 2 seconds. Yeah, that will be 3 milliseconds, about that. 3 milliseconds. Yeah, it's quite consistent. Maybe I want to do it a little bit faster because it's just a little bit slow, I feel like. Be twice as fast. Twice as inaccurate, but it should still be fine. Yeah, that's fine, that's fine. So 3.3 milliseconds right now to render 4 by 4 by 4 of these guys. So right now we are rendering 4 cubed times 32 cubed voxels. So 4 by 4 is 16, times 4 is 64, times 32,000 is what? Wait, that is again 32 times 32 times 32 times 1,000. So that is 32 million, right? 32 million. No, wait. What the heck is this math? Why? Since when is 64 the same as 32 times 32? Ooh, that one hurts. That one hurt deep into my soul. 64 times 32 times 1,000. How much is it? It's 2 million. It's still nice though. 2 million voxels. You tried to render at half the resolution and then upscaling 2x of bilinear scanning. I'm not sure if that will really accomplish anything. I mean, you can. Yeah, but I'm only rendering right now in like, what was it again, like 1280 by 720? Yeah, so it's not, you know, very large resolution or anything. So I think this is fine. Now, to be fair, you are right in the sense that, you know, with all of the straight edges that we have, just using linear interpolation would totally work. Right, that would totally work. Oh, we have to do something with like anti-aliasing as well. Just look at that. Very much. Okay, but right now we are at about 3.3 milliseconds, right? Let us do something in the vertex shader about that. So currently, what we can do... I guess it shouldn't be in the vertex shader, it should be in the geometry shader. Right, because the vertex shader doesn't know anything about faces just yet. So I should have some sort of uniform. Where do I have those here? All the way at the end. Okay, uniform. And I should have like vec3. And then camera direction. Right? Like cam dir equals vec3 of zeros. That actually doesn't make any sense. Like of ones, I guess. Mid mapping. Mid mapping doesn't necessarily help too much with anti-aliasing, right? At least not for us, because we are not using any textures. We could, if we wanted to be really cheeky, right? And I've been thinking about this, and I think I will employ this at some point, but definitely not for everything. If we have one big face, let's say there are like 3x2 voxels, and you know I need to render all these 6 faces, then what I might as well do, might as well say, well, let's just create a texture with these 6 colors, and then I'm just going to render one quad like this with those textures on top. And that might work, but that really does not work with our geometry shader. The noise texture looks like my brain right now. It might be because its noise and jitter ain't helping. Yeah. Yeah. No, that's very true. Okay. What I want to check first... Right, let's make this 12. What I want to check first is the normal with the cam there. So I have to say like dot, like if dot with north, because this is the north face, with the cam there, and the camera there is pointing towards the normal. It's like the camera direction is pointing towards the face, right? So a dot product with the normal of that face should be negative. So if this is smaller than 0, and then the rest. And so I want to check this one first, because for half of these this will always not be true. But this will probably also not be true for a lot of them. No, wait, because for the ones that have a lot of occluded faces, we just don't upload them anymore. Yeah, I'm not sure. This is probably the cheapest operation, so I should probably do it the other way around. Actually. I don't think it really matters. This one is the cheapest, I think, because it's only one lookup, which is basically always the same thing. So maybe I can just load that in somewhere. It is one and then it is an equal operator. While this is a dot product of 2, 3 vectors. So it has to do quite a lot of multiplication and addition in here. And then is smaller than 0. I do believe that the graphics card has like optimized hardware for stuff like this, for dot products. But still. Okay, so now I need to add this to every face. Then of course this one should be east. That one should be south. Shouldn't you normalize the vectors or something? No, actually it doesn't matter because we only need to check if we are smaller or bigger than 0. We don't really care about the actual size of the thing. We only care about its direction, so to speak. Oh, I added the ends twice. This one is west. And this one is top, right? Yeah. And this one is bottom. Okay. I think this should work. Right now, I've initialized it to a 111 vector. So you should only see it. Yeah, this. 111 is, yeah, looking like this actually. Right, one in the X direction, one in the Z direction, and one in the Y direction. For the X, it's not working. Like you can see that we are only using 2.4, 2.1, so it is again a lot faster. Yeah, the north and south. No. Yeah, the north and south don't work. For some reason. The other ones do. That's weird. I think the north and south vector is just flipped around for some reason. Oh, it is, isn't it? Because we're working in brand new. Welcome to the stream. Nice to see you. Right, because in OpenGL we are working in like the negative Z space. So actually, yeah, this is flipped around. So it should be bigger than 0. It's really confusing, and I'm not really sure how to turn that around properly. I guess I should do something with like the projection matrix now. Now it should work. Let's see what the speeds are actually like. Oh, we are going back to 3. Oh, that was because I went out of the game. That makes sense. So if we do all 3 at once, like this. Yeah, so it used to be 3.3 and now we're back to 2. Like that camera trick makes such a big difference. Like in principle, it should divide by 2, right? Almost. It's not quite that way, but you know, the principle is there. And now we are only outputting 12 vertices every time instead of 36. This is a ×3 improvement from where we started today. So that's just amazing. Oh, I love it. Okay, let's go to program, I guess. No, actually in C engine, I want to switch the projection matrix around. So I want to say that's projection matrix, and then I want to say, well, times matrix 4 dot rotate around the y-axis by exactly pi, exactly math.pi. Of course, it has to be a float. Okay. Okay, now of course some stuff here is inverted. This looks very trippy. Holy. Oh, this is insane. I think, right? I got this nasty feeling that maybe I have to do it the other way around. Like this. Yeah, I have to do it the other way around. Now things are inverted this way. But that's okay, we can live with that. So when we go to world, we no longer have to put it in the negative Z direction. We can put it in the positive Z direction. As we would want to. And then we have to switch A and D around. And then geometry shader, we have to switch D spec. And then everything should be fixed. Oh, hell yes. Oh, hell yes. We do be doing it. Right, so in program, the D and the A should be switched. Right, because, yeah, this should be minus there, that should be there. We were already confused about that last time, weren't we? That was switched around, while it shouldn't have been. Oh, now up and down is also switched around. Also, this is very bright. We were on the... we were on the dark side of the moon all this time, and now we're on the bright side. Which makes quite the difference, apparently. Okay, unit there, yeah, that's fine. When we move our mouse... What was it? We have to flick this around. Minus X? No, it was definitely plus X. I guess it was minus Y then. Is the lighting calculated every frame? Yes. Yes, right now it is. Ooh. Hold up. That's still not quite right. Now north and east are switched around. Yeah, because we are just rotating and not mirroring, I guess. How do we mirror? Is that even possible to do that with a matrix? Yeah. Because we are rotating, we still have the same issue, but now just rotate it to another side. Mirror matrix, does that even exist? OpenGL, perhaps. Mirror matrices. Mirror multiplication to mirror. Okay, I assume you have a point P that you want to reflect across a plane with normal N. Pick any vertex on the plane and call it V. Now calculate d pv.n, blah blah, I really don't care. Can't you just go if frac normal equals north, lighting open 7? Right now, yes, but I do want a moving sun. You know? Well, like in Minecraft, where the lighting does dynamically update as well. Because I do also want shadows and all of that fun stuff. Because it's gonna be cubes with static faces, right? Yeah. So the cubes are going to be static, but the light source won't be. So I should plane A, plane B, plane C, and then you have like this great thing. Can like someone just the matrix with elements? Oh, you just literally just do that, huh? That actually makes a lot of sense. Hold up. So in here, right? Not in program, in C engine. Can we create a matrix like that? Matrix that's identity, basically. It's basically an identity. Inverted clear rotation, clear scale, normalized. And then we can do column 2. Then we have to say Z. Not an invert in the Z. Something like that. It'll probably be faster. Oh, then you just create a separate shader for that and use a plane or decal for the shadow and overlay it on the original thingy. Make a separate shader for that. You mean like for the shadows? And use a plane or decal for the shadow and overlay it on the original thing. Yeah, I still need to think about that. Maybe we can do it in like a smart way. A static object shader. Yeah, but I mean, yeah, like all the objects are going to... No, wait, not all objects will be static, but the terrain at least will be semi-static, you know? But it's the lighting itself. Changes directions. And I guess I can get away with just setting static lightings. No, wait, that actually doesn't work, because then at some point of the day, the lighting will be at the exact opposite side of the voxel, right? Then it will look odd. But maybe you can do some matrix trickery there. But this is actually very possible. Identity equals just matrix.identity. Then I want to do identity dot, and then I have to get a certain thing. Can't I just do it like this way? Yeah, so row is 3, no, 0, 1, 2, and then column is 2. I need to set that to minus 1.0f. Yeah. Oh, the lighting changed directions, yes. Guess it should be mirror. Then we just want to mirror in the Z direction. Like this. Okay. Now everything is just slightly odd. Not gonna lie. Everything is the other way around right now. Yes. That is a bit of a problem, isn't it? Like everything. So also all of the rotations, all of the goal faces are now the other way around. Okay, let's get the movement right first. Wait. So A and D are mirrored again. Like again. So I guess I do have to do A and D the other way around. Fine. Okay, and then the X needs to be moved around as well. Am I making it any better this way? Like this still works. Now here nothing works, so I'm guessing that yes, as soon as I invert my things, it should work. So if I run it right now, right, the thing in front of me is just not rendering, and I'm rendering the bottom, like the wrong sides here. So I think if I go into my geometry shader, and I say something like, move these around, right? This should be 0, 1, and this should be 0, 1. I have to do that for every single side. Do it here as well. Did I start at the top? I didn't even start at the top. I'm so great at this stuff, because now I just don't know anymore. Oh, that's awesome. Where did I start? I think I did these. I think I did these. Then I need to do number 3. 0, 1, 1, 0. And then I need to do the first 3 as well. This is 1, 0, 0, 1, yeah. This way. And the second one is these two. 0, 1, 0, 1. And then here it's these two. 0, 1, 0, 1. Okay, okay, okay. Almost. I suppose I now also have to like change this camera direction. No, that doesn't make any sense. Yes, that doesn't make any... No, this doesn't make any sense, boys. I think I just royally messed this one up. Yeah, so now Z is just mirrored, right? In every single way. Why do I get these weird results that way? Yeah, like here I'm getting weird, very weird and trippy effects, so this definitely does not work. Yeah, and here I'm just flipping every Z value, right? The rest is still exactly the same. No? That's just 1, 1, minus 1, 1. Yeah. Only flipping the Z value. But it gives me such weird results. Because now, like this I can't see. I can't see up. And these are like the bottom side, so that is fine. I can also see this. Oh, you know what? Maybe it's not that bad. It's only the north side again. That's messed up. If I go to the geometry shader. Yeah, north is still the same. And this fixes it. It's not a rotation issue, it's an actual camera issue. It is a rotation issue. Oh, hold up. It's not a camera issue, it's a rotation issue. Then it's actually very possible that we did do it correctly. We just messed up the rotation here. Oh, hold up. Hold up. So this should be 0, 1, 0, 1. Right? No, then it still doesn't work. It does. If I then also make this bigger than 0. Now I see the backside. Oh wait, north is now the other way, right? North and south has been switched around. Because of the mirroring. So actually I'm not even looking at north, I'm looking at south here. Yeah, so I actually have to move these two around now. So this would be south. Yeah, and this would be north. Okay, so let's make this one bigger than 0, see if this works. No, good, 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 good. That's what I want to see. Like, I can switch north and south around, that's fine. Not too attached to my directions. Yes, this works. Okay, hold up, this actually works. Then I need to switch the south around as well, like this. Okay, now I'm pretty sure that all of it works. The way that it should work. Kind of. Then this one's south and this one's north. And now I just have to change my naming convention everywhere and then it's fine. So this one is now south, this one's now north. Right, or even better, I'll call it north and south. And I'll just change these two around. When I put them in. Right, so if I go to render manager. Now, so this one is north. Yeah, K plus 1 is north. Wait, that actually makes sense. No, this is north. That is north. Right, and this is south. I think that is just the way that we define it. Like the -1 direction is south, the +1 direction is north. Right? Oh, so we are just looking onto the south side. Yeah, that actually makes sense. We are looking onto the south side, right? We're looking in a north direction, therefore we are looking onto the south side of the actual cube. Hold up, that makes total sense. So this is north, and this is south. And then here too, like this is south, and this is north. Yes. And if we are looking in the west direction, which is this way, we should see the east side Like this should be the east side of the voxel, so meaning that if I change the east side here, I mess that up, then I shouldn't see the east side anymore. It should be here. Oh. Pain. It's painful. So did I mess up my east and west side then? East is I+1. So east is in the direction of... Oh, that's in the +1 direction. Yeah, so I'm looking onto the west side. I'm such a goofball, boys. So yeah, it is the west side that we are looking onto. We are looking in the east direction, but the west side is looking back. Oh, that is... Thinking I have to use my brain here, but yes. Whew. I think it works. I think this works. Okay. So we have a working system right now that is beautiful in every single way, and you cannot convince me otherwise. On the other hand, it's fast. Like, we can render this stuff in 2 seconds, 2 milliseconds, and it is 2 million voxels. One block of 2 million voxels. Of course, we are not actually drawing 2 million voxels, but it's close. W should be in minus deer. Oh, there should now be in minus deer, there should be in plus deer. Oh, the deer is flipped around as well. Oh, that is probably why. Deer is flipped around. Right, because now I need to move in minus deer to go forward. So that doesn't make any sense, of course. Let's go to the camera. We're just fixing bugs right now. Get direction. Yeah, do I just not need to invert it anymore? Now this is forward and backwards. A and D. Yeah, so I just don't need... Oh, I'm off. Bye, boys. I guess the, like, rotation should be, like, inverted or something. No. Shouldn't the camera movement be in cuboid game instead of engine? Oh, this is really bad. Let's get rid of this. Yes and no. So the thing is, right? In program, so in our game, in cuboid, yeah, so this would be cuboid game. In here we actually control it. So in here we say engine.camera direction, and then engine.accelerate camera. So we do actually totally control the direction and the movement of our camera in the game. But the camera class itself is within the engine. Yeah, so you can't make your own camera class. That's because I won't have all of this nonsense hidden away. So the direction of the camera by default is, I guess, in the +C direction. For some, yeah, that makes sense, right? Like in the north-facing direction. Yes, but why does this do what it does? So we have forwards, which is the same thing as we are using here. Here in minus here. Does this actually work now? Oh wait, this is still moved around. Hold up. So if we go into camera and we dot invert this. This one, dot inverted. It doesn't change anything. What happens if you set drag to 0? Then we will just move on forever. Right? Then we don't decrease our velocity over time. So we will just rack up and rack up and rack up more velocity. Here, we'll just like fly off in a second. And I can of course accelerate the other direction with S now. But if I let go, and we just keep going. Yeah. Awesome. Do it. Yes, I did it. I already did. Oh, the chat delay or the stream delay, one of the two. Someone's the culprit here. So this should be the minus unit Z direction, I guess. I guess the default direction is actually in the minus Z direction. And we are just transforming it in a funny way. Okay, let's set the program. Maybe only have drag when not moving. Yeah, the thing about not moving is that it is actually very hard to determine when you're not moving. Like sometimes, well, yeah, you'd have to check if float's velocity in every single direction is exactly 0, and you'd have to check that every single frame, right? And even if you like add something like gravity, it will get even more messy. So I don't really like that. It's such a simple operation, I don't really care about one float multiplication. A, and then these turn around. Yeah, look, this works. If none of the keys are pressed, then apply drag. If none of the keys are pressed, then apply drag. Well, but then you could just accelerate infinitely. Like when you are pressing keys. So that isn't quite what I want either. And if you only apply it when you are pressing keys, or when you aren't pressing keys, I mean, well then you still have residual motion left, so it's not necessarily that easy. I mean, you could do it, definitely. You just have to check if your velocity is actually 0. But that's an extra check that you have to do, instead of a multiplication, which, you know, multiplications, floating point multiplications are very, very fast anyway. So it's fine. So right now, I want to be able to upload that vector to whatever thing we have here. Right. We have something here. Shader manager, shaders, uniform matrices. Oh yeah, we actually have this. This is just uniform matrices. I want to change this to uniforms. So then I can also put vectors in here. Uniforms. Everything is changed automatically. Awesome. Uniforms. Dot, and then I want camera direction vector. I guess I should add that as well. Camera direction vector. It should be cam here. There we go. Right. And then in the camera, we have an update method, and we should actually probably update. Well, I guess that should be in world, right? So in world, we already set a matrix here. We get the camera matrix, and then we set the camera matrix. Then we should probably also do something like cengine. That's set shader program uniform and then vector. Shaders, the default shader ID. Ref doesn't maybe even have to be a ref. You can just do cam matrix. Oh, that's the matrix actually. Let's do the camera direction. Then uniform. Camera matrix, camera direction vector, like this. Okay. Now where does this all lead? So let's actually copy this. And we actually know what we are looking for. Actually, I guess I can just copy this, right? Easier. Set shader program uniform and then vector. And we'll start off with a vector 3D. But I guess we can have a couple of overloads here. Vector 3D vector. Set uniform vector. And this should be vector. Okay, do the same thing here, just copy paste. I guess that just kind of works. I'm using 3D, but it should just be... Okay, I've been using the eigen thing too much. The eigen library in C++. which does kind of require you to just use these here. But I don't want doubles in my game, because they take up double the amount of space. Uniform effects. I don't think it actually matters on x64. If you're using any CPU now, maybe you should actually go to x64 specifically. Okay, asset manager, GL use program, get uniform location. Oh, this should just be get matrix or get uniform type. Should be uniform helper. Should be get uniform name. I don't know why I didn't do it like this yet. Why I didn't do it so universally yet. Get rid of all these matrices and just use uniforms. Get matrix. It should be vector. Oh, this should be gl.uniform3. Right, and then uniform and vector. There we go. Yeah, that is perfect. This is matrix type, this should just be uniform type. Uniform type. I guess I should do that in here as well. And then I should change everything in C engine. Uniform type, uniform type, uniform type, uniform type. Change everything in world. It is already changed. Anything else that I didn't change? Probably, right? But at least I'm uploading the camera direction right now. Okay, so now we should be able to see the exact opposite of all sides at all times. Awesome. Why? Do I even want to think about this? I mean, I can just change all of these to be positive and then it works, right? So the north side, the one that points to the north, yeah, that's one. And then the dot, the camera direction, with the camera direction pointing towards it. I don't even know. Let's just make it positive and be happy. If everything else works now, I don't want to change everything back. Because there's one thing that that just seems a little bit odd. It's fine. Famous last words. Okay, there we go. And now we should be able to see every face at all times with a stunning 2 milliseconds per frame. Of course, it was 3 milliseconds because I tapped out. Then it just stops counting for a second. But these are the faces that we were always able to see, but now I should also be able to see not the bottom like this. Then when I change... Oh, I still can't see it. Oh, that's weird. Yeah, like this does change. I guess I do need a little bit of freedom in here. Because that seems a little bit weird. What happens if dot normal cam there is equal to 0? That means that the... Oh, hold up. Aren't I making the mistake there? If it's equal to 0, then they are perfectly perpendicular to each other. So that means that, let's say this north normal is pointing this way and my camera is pointing exactly that way, then they are perfectly perpendicular. And the dot product is 0. Why does the top like never work? Like, I can move this to the top or to the bottom, but that just doesn't make a difference for some reason. And then in here, the bottom, oh, the bottom does work. You can see, like the bottom does work. So it's very specifically the top that doesn't work. Top, cam there. Top, cam there, bigger than 0. Oh, you think that this is like turned around? Should be 1, 0, 1, 0. You think that's the issue? Very likely. This looks pretty though. Random but pretty. Yeah, here we go. Okay, but I guess I should give it a little bit of leeway. Because this is still within my frustum, right? So I should, I guess, have the camera position. Yeah. Because right now I'm looking up a little bit. But if there was like another thing up here, like another cube up here, then I would see the bottom, but I would also see the top of this one. So it's not quite as easy as I thought, actually. Yeah. So I should get the position of my camera. And then see if the position of my camera, like what kind of vector it can make with the location of where I'm rendering. And if that angle is too big, then I can't draw it anymore. But what exactly that angle is, I don't know. You're random but pretty. Yeah, this thing is very random but pretty. Yeah, so I would have to just get the position. The position of my camera, not the direction of my camera. And then actually get a normalized direction from the camera to the center of the voxel that I'm drawing. And then get like a certain angle from that. That is still... That's pretty nasty though, that's pretty nasty, not gonna lie. I'll think about that one. I'm not going to do that right now, I think about that one. Okay. Well, this is nice. I think we have time to do one more thing, and what I want to do as well, what I did think about already, was add some more chunks in here, so that we can actually check the chunks around. And then we don't have to have these in-between areas, you know? So we can actually have stuff like chunk, top. Or I guess we could start with north, then we can have chunk south, chunk, chunk east, chunk west, chunk top, and then chunk bottom. Right, so that's quite a bit. So now in here I have to check if this is true, or... Right, so if I is smaller than length -1, which means I'm still looking within my own chunk, and the voxel in my own chunk is that's of alpha 3, so that means that it is fully like opaque, then that is blocked. Or if chunk, I guess I could make these like question marks, and I can also like add nulls to them if I'm on the borders. Or chunk east. This. And then that. I don't think that works. If chunk east doesn't equal null. Chunk east dot hash value. Ah yeah. If chunk east dot hash value and chunk east dot value. And then get voxel, I guess. And that should be I0, and then J and K should be the same. And then dot alpha double equals 3. Okay, so this is quite a wide thing. It's pretty wide, not gonna lie. Okay, it will work for now. I think maybe I should make a little function for this. Right. Then I should have this. No, other way around. This one, or I'll just copy these. Alt and then paste. Alt is my favorite key in the like everything. This is west, chunk west, chunk west. This is top bottom, chunk top, chunk top. Are you a top or are you a bottom? Great questions. North and south. There we go. I almost wanted to click reformat, but I don't dare to do that now. Okay. So now in render world, or in just world in general, didn't update that yet. Don't know why. Oh, this is a C engine thing. Oh, yeah, of course. No, that makes sense. It has to go through C engine first. Yeah, of course. So let's just copy this. Go through C engine. This will be a really long function. Top, bottom, blah, blah, blah. And then this has to be chunk north, chunk south, chunk east, chunk west, chunk top, chunk bottom. Okay. Reformat. Oh, that's also a little bit painful. Okay. And then in worlds, yeah, then we have a problem. So I guess here I should say for north, right? So it's C greater or equal to 0 and Z smaller than 4. I guess I could just make like an int size here. An int size equals 4. Everything here is smaller than size. We can make bigger cubes. And it is smaller than size. Right. Then the chunk to the north. Wait, this is chunk to the north. So that just means Z smaller than size. Then it should be chunks. Oh, that's going to be a pain, isn't it? Oh, that's gonna be a pain. Yeah, because this is going to be x plus size times y plus size times z. Be very long in size. Smaller than size minus 1. And then I need z plus 1. Right. Now this is not going to be a huge function at all. Yeah, I might need to think of something smarter. 1, 2, 3, 4, 5. One more. Oh wait, an else. Null, right? Assignable? What do you mean that's not assignable? That's either null or not null, right? How is this not assignable? If I actually do this, that's not assignable. Oh no, that's fine. Oh, that's because I had this here. Yeah, this is not assignable because this gives me a... Oh, it gives me an ID. Oh, hold up. It gives me an ID. Oh, but everything is chunk here. Oh, of course, everything is chunk here. Hold up. So it's fine. I can just add chunk to everything here. Hold up, it's not that bad. Because I'm not actually generating different chunks for everything that I'm rendering, because we're just checking out the rendering at this point in time. Okay, yeah, we can do this. We can add 6 times the same chunk. It's totally fine. It's not weird at all. Let's see. And now we see nothing. Oh yeah, of course, because now things... Right, so chunk north still needs to be... Because right now it's just putting chunks where no chunks exist. So I have to do something like, well, if... X, no, Z... smaller than size... -1, then chunk... Otherwise null. And this is of course not quite correct for some reason. No plus conversion between chunk and null. Should be a chunk question mark. Yeah, there we go. Okay, let's do this a bunch of times. So 2, 3, 4, 5, 6. Should do it. So Z is the same thing, but it should be greater than 0. East should be X smaller than size -1. West means X greater than 0. Not greater or equal to, greater than 0. Question mark. Then this one is Y. Top is Y smaller than size. Yeah, and the other one is Y greater than 0. No, that's not weird at all. This is totally fine. Every major game development producer does this, boys. I'm sure like all the EA Frostbite engine code is just filled with spaghetti code and just random stuff. How's performance? And how is it rendered? Just wondering. Performance is actually great right now. So we are drawing 2 million voxels within 2 milliseconds. And we can probably just bump it up a notch. Double it. We render this in 2 still. That's insane. Oh really? We actually render this in 2 milliseconds. Holy crap. I'd expected the GPU to start struggling a little bit. Okay, so this is... I'm just gonna... I'll just let it run, apparently it doesn't matter. So right now, rendering 32 times 32 times 32. And then 8 cubed times. So times 8 times 8 times 8, right? So we're doing 8 by 8 by 8 of these chunks. Which in total is 16 million voxels. 2 milliseconds. Heck yeah. That isn't a big win. How is it technically the rendering? Okay, I'll show you here. So if we go through here. Blah, 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 blah. And there's nothing. So basically what we're doing right now in the render manager is we are going over every single voxel and we are checking, even in like neighboring chunks, if certain sides of the voxel are covered or not. Like there's another voxel there, so then it doesn't need to be rendered, right? If all the sides of the voxel are covered up, it's not true. It's yes. So if we take this into account, right? If all the voxels are, or if all the sides of the voxel are covered up, then we are not even sending it to the graphics card. So yes, technically speaking, it is only like the very outer edges right now that we are actually sending to the graphics card. So that is 32 by 32, right? And then by 8 by 8. And then that by 6. So it's really only 40,000. But that is like a huge difference. I'm having issues with well-optimized chunks at like 32 by 32 by 50. Yeah, how are you drawing it? Because, of course, I'm not sure how much of the streams you've seen, but we are using geometry shaders. So we are only sending, I believe, 4 bytes right now. Yeah, 4 bytes to the graphics card. Here, my vertex array. I'm only taking in 1 uint data, and I'm deconstructing that into like the position of the voxel and the color of the voxel. And I'm using the geometry shader to actually create all the triangles around the position. And that makes a huge difference in data. I'm drawing meshes, yes. Yeah, so see, the issue is you are probably using like 9 floats. You're using 3 for all the normals. Right, for every triangle actually. You are using 3 floats for the 3 normals. You're using 3 floats for the 3 vertices. You're even using more, right? 3 times 3. You're using 9 floats for the vertices. Could you try to use some alpha voxels? Oh, yeah, I will actually try that. That's a great idea, Federico. But yes, in any case, drawing meshes requires so much data that just the data transfer alone is ridiculously slow. And it's just not even funny anymore. And geometry shaders aren't particularly fast, but compared to that, yes, they do the job. Yeah, it's just a problem with making a 3D like voxel engine, is that it scales very, very, very fast. So yeah, right now we are already, like in principle, right? Like in technicality, sure, it's not true, but in principle, this is already 16 million voxels. Right? And it doesn't look that big. Honestly, it doesn't look that big. If you just stand here, it's not that big. Already 16 million voxels. If you have to draw this out like 1 voxel at a time, your GPU will die way before it's even halfway there. So that's the thing, it just scales so quickly. Yeah, if you just make a like a normal terrain, quote unquote, you know, with just some like we did in No Number game, with just some heights, like a height map, and you just connect those vertices, you know, some triangles, and you just have 1 layer of triangles. Like, that's totally fine. You can draw quite a lot, because that's just in 2D, right? But this is in 3D, so it scales faster. Yeah, so could we try some alpha voxels? I definitely want to try. So let's do that. Let's go to worlds. I do need to make this smaller then, because we're going to have to see a lot more voxels right now. Let's actually make that 2 even, just to be sure, because yesterday the stream almost died because my GPU was not having it. Where do we generate it? So chunk 1, we are generating that one here, and we are just shoving in the 2 here. If we make everything semi-see-through, so if we say like the alpha is not 3, but we make it 2, so it's a little bit see-through. Time to start googling geometry shaders, so that I have that for my next development session. Yes. This doesn't look very alpha to you. It doesn't look that to me, I mean. But like everything is being drawn here. So I guess even the geometry shader knows that the alpha is there. Fragment shader? Are we just forcibly putting 1s? Out. But times light, what is frag color? We make that in the geometry shader. What is frag color? Is geom color. Let's go to the vertex shader. RGB A, okay. So I guess that should be fine. Yeah, let's see. Maybe I should just enable GL blend and all of that. Maybe that makes sense. Oh wait, maybe I'm just not drawing things back to front, now that I think about it. Okay, let's first enable GL blend. Let's go here. GL.enable. Enable cap. Blend, and then GL blend function. It's like blending factor. Wasn't it like blending factor alpha? Source alpha, was it source alpha? I think so. GL blend should do it if they share object. Yeah, I might need to draw them in the correct order, but we'll see. And then blending factor 1 minus alpha, right? 1 minus destination. I don't know which one should be source, which one should be destination. Yeah. Like, it looks cool, right? Looks like a gumball machine. But the things behind here are just not shown. You see? Like, they are just not drawn. If you look at it the other way, like this, now you can see that things are being drawn behind here. That looks trippy as hell. Oh, that's beautiful. Have you ever wondered what it was like to live in a gumball machine? Well, now you know. Oh, this is even... Oh, that's... Oh yeah, that's the camera. Don't mind the camera. 1 minus source alpha, I think. Just source alpha, 1 minus source alpha? Oh, I'm not sure about that one. That looks weird. Engine, maybe it's destination. Yes. Of course, there's no correct way to do this. I actually like the way that we had it, so. There's no definite correct way to do it. That's why you have all of those things there, all of those different options. But yes. Like, cue that inside out meme. Have you ever wondered what was going on in someone's head? Someone's gumball machine? Well, this is it, boys. This is it. It ain't gonna get better than this. Bloop. Yeah, that's actually kind of a big deal. This. Because I would actually have to draw back the front. And I have no idea how I'm going to manage to do that. You see. So you only try and render a voxel if it could be seen, checking neighboring alphas, etc. Yes. That is exactly what I'm doing. Yeah, like it's like, get the voxel that is next to here. If the alpha is 3, then it is covered, so I'm setting this 1 bit to 1. It's occluded, I guess. I think I know a BTF rendering idea. Right? Right? You want to tell me? Now I'm curious. Okay. This is a bit of a thing, right? We have a couple of dead ends right now. We have this thing with our camera that some faces like appear and disappear because it's not quite correct. Do a small flood fill from as far from the camera forwards as possible. So add voxels from that direction. Yeah, I'm going to have to look into that flood fill, you say? I'll actually just write that down. I'll do some research into that. Like how I can actually facilitate that. So add voxels from that direction. Yeah, like I understand, right? You want to render back to front, was it? pretty sure. So you kind of have to figure out all these different positions. But yes, many math, and it's late, and I don't feel like doing many math right now. So we have that one, and so we have the camera, and we have this alpha issue. So these are two issues that I kind of have to just think about. I'll just sit on it. I mean, I have the weekend now. This is Friday. I'll stream again on Monday. So I'll have some time to think about it, look some stuff up. Yeah, then I'll let you all know what comes from that coming Monday. For now, I actually have a video on the main channel that is gonna come out in 20 minutes from now. So that is something to look forward to. It's actually a pretty cool video. I kind of just came up with the idea on the spot this afternoon. I didn't have anything planned for It's Friday. All of a sudden I just saw this thing and I was like, yes, I want to make a video on this. And I just worked the entire afternoon and got the video together, uploaded it, and it's there right now. Or, well, in about 15 minutes and a little bit. Right. For now, the stream, I think I'm gonna get out of here. I don't know what to tell you, but my brain is fried, and I just want to sit back and I don't know, watch like a Netflix series or something. Also, dynamic camera lighting, that looks like it's dynamic camera lighting. Yeah. Back to front. And doing camera lighting. All sorts of stuff that I just don't want to think about on my Friday evening, I guess. Oh, it's getting darker the further you get in. Oh, like that. I guess you get like the kind of fog effect here, right? So this is what it should look like, I think, at least. At least going in the forward direction. The upward direction, you can see that some voxels are clearly missing up top here. But from camera to back, you can see like this fog effect. So I think I'm kind of happy with that. I think that looks fine. Yeah, because like in game, you're never really going to stand in a block anyway. I guess you could stand next to it and then you'd see like this fog effect. Yeah, I'm happy with that. I'm happy with that. Okay. I think I'm just gonna close this up. And yeah, hope you all enjoyed. I'll be back on Monday, like I said, on 8 PM CST, like always. Tuesday, Thursday, Wednesday, I forgot the day. Thursday and Friday. Yes, all of those. And hope to see you there. If you haven't subscribed already, of course, you can subscribe. You'll get notified whenever we actually go live. And yeah, that'll be it. My brain is dead. I'll see you later. Bye-bye.